So let's go with the whiteboard itself. Yeah, because PowerPoint was comfortable, but now you are able to see whiteboard. You are able to see now, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yeah. So what I'm trying to convey is that suppose I have a generator. Now you are able to see clearly. Suppose
Yes, sir.
okay, yeah. Now suppose I have an impedance like this. Hmm. So whose value is j is equal to 1. Okay. Then I connect it. See, I'm connecting various impedances in a network. First of all, I'll explain you what is bus impedance matrix and how the equations are formed there. So your confusion will go away.
Yes, sir.
Okay. So because this part, and I'll send you the book also. Okay, from where I have taken this, so you can go through the book
Right,
also.
sir.
Okay, I'll email you the book.
Yes, sir.
This is one more part of the network. Okay. So this value is, see, this point from here to here, it is j point 4. Okay, from here to here I have its impedance is j point 2. So from here to here I'll keep a value of j 0.08. This is the value
Okay.
of this. Yeah, I'll be explaining you, don't worry. Let me draw it first. And this value
Yes,
is
sir.
j 0.2. Now basically what happens is that in nodal solution what we do is that we will write for nodal analysis. If we have to do a nodal analysis, what we write KCL equations. First we
Correct.
write the KCL equations and impedance. See, impedance, our current would be equal to V voltage into your, this value is called, Y is called as admittance. This value is called admittance. What is admittance? Admittance is Z is your impedance. The
Yes,
reverse
sir.
of impedance is called as admittance. So your Y is
1/z.
Y would be equal to 1 by Z. This is called as impedance. So when I'm drawing any of the networks over here, you have seen the network. So what I do is that in this network, I have drawn this in form of the impedance value. So this I have drawn in form of the Z value. This
Right, sir.
every whatever value it is here, it is in the form of Z value. So you, as you know that my Yij, if this is one line, okay, this is a bus one point. This is my second point. This is my third point, and this is my fourth point. Okay. Now you
Yes,
notice
sir.
that suppose in these points, what I want is that I want to write this equation in this form. I is equal to B into Y form. Okay. So the equations which I will get by writing I is equal to B into Y form, and the corresponding matrix that I'll get is called as the admittance matrix, or is properly known as bus admittance matrix. Okay. So
Right, sir.
of course I know that the first current that I see is that, see, this is J1. So Y would be equal to, again, Y is 1 divided by J of 1. So yesterday I have told you 1 by J is nothing but, how much is the value of 1 by J? Can you tell me? 1 by J is nothing but minus J. In yesterday's class I have taught you 1 by J
Yes,
is
sir.
equal to minus J. Do you remember that? So if
Yes,
I
sir.
have,
Sir, one second, sir.
yeah,
Sir, is that J 0.8 at the second node?
at the,
The
this is zero
the
point 0.4, 0.8. Yeah, at the second node this is 0.8.
Yes, sir.
This
Yes,
is
sir.
0
Thank
point.
you.
The value is 0.8. Now,
Thank you, sir.
can you convert this corresponding? Now, if I have to write the same thing in terms of, now this J1 is there, right? If I have to write
Yes,
this
sir.
J1 in terms of Y, how do I go about it? What value I will write for that? Can you tell me what would be the value there?
Uh,
Yeah, here it would be, instead of the value there, instead of,
um,
yeah, minus, it would be minus J,
sir,
right?
sir, minus. Yes, sir. Minus J. Yeah,
Minus J.
precisely.
The value would be minus J. Okay, so
Yes, sir.
similarly, can you tell me what would be the value of J here if I express it in terms of Y? So
Sir,
what I am to,
minus.
point 0.4 is, oh yeah, minus, yeah, tell me, good, minus how
Sir,
much?
one second. Just quickly calculate.
Yeah, So it is nothing but as 1 by j into zero point 0.4. So
Yes, sir. One by j into point.
this j value, see, now you see this is
Sir, that
line,
is minus
uh, uh,
j minus 2.5 j or minus
yeah,
j
correct,
2.5.
exactly the same. Similarly, you can calculate here also, it would be all the values would be. Now you see that this first line is there going in, okay. This is the first line which is not connected to any part. So how do I represent this first line? In order to represent the same line, what I do is that I will write it in form of, yeah, let me take this color. Somehow it goes, yeah. I'll write it in form of current. Suppose the current is entering this node. Okay, first of all, I have to show you this current. Here I say that current I1 is entering here at this point. Current I1 is entering, and this is the ground connection over here. Okay, so the first point here would become, the value of the impedance will become minus J1. Okay, on
Yes,
similar
sir.
grounds, this is the point 1 and this is the point 2. So this in admittance will, the line is Y12. Okay, this is line 1 and this is line 3. So the line is Y13 between this one point and third point. Can you tell me what is this line? Y between 2 and 3, what would be the line?
Sir,
See, for,
point two.
no, between 2 and
Oh,
3,
okay, two
like
three. Okay, y two three. Y
Y2.
two three. Y
Very good. Nice. Between 3 and 4, what would be the line? Here,
sir, y
to
three three
Y3, 4.
four.
So we have this first, we have to assign this value. Now the first value we have expressed in terms of Y, but the other values we haven't yet assigned. So other values, I'll rub these values. You have noted down the J.4. I will write it in terms of
Yes,
Y.
sir. I have, sir.
I will write it in terms of Y. Now all the values over here, if I have to express in terms of Y, I have to go about it. Yeah, I will. So it would be. Can you write by that time? Can you write everything you have to do 1 by J? So
Yes,
what
sir.
would, yeah, everything, whatever value you are writing, you have to do 1 by J. So here 1 by J, you just now saw it was minus J 2.5, correct?
Yes, sir. Minus
And
j.
the
Yes, sir.
other value you saw would be minus inverse of that value which was there.
Yes,
What
sir.
was the
One by. Yes, sir.
1 by point
One by
0.8,
0.8.
point 0.8,
Yes, sir.
and obviously 1 by J value will be coming in terms of minus. So this
Yeah,
is coming
negative. Yeah.
minus J 1.25. Okay, suppose there is one more, one current that is entering this node. Okay, this current is I2, right? And
Okay.
yeah, and now other values, this was this value Y23, earlier it was J 0.2. So 1 divided by
Yes, sir.
0.2
Point
into
two.
1 by J, that would be equal to 10 by 2, that would be equal to 5. So it would be equal to
Yes, sir.
minus J5,
Minus j5.
minus J5, right? On similar
And
grounds, it is
similarly, there also
there also, it would be
minus
equal to minus
j5.
J5, minus J5. Very good. So you're following, nice. And between Y34, again between Y34,
One by 0.08
uh, uh,
into one
minus
by j.
J1 1.25, because
Yes.
earlier also you saw that this was minus J 1.25. So one thing,
Basically,
yeah,
minus j 12.5.
not 12.5, 1.2. Yeah, 12.5, correct. 12.5. It is 12.5. You are correct, exactly correct. So now you have to notice. See, if you now apply the circuit analysis to this equation, now you notice in terms of admittance and transformation, transmit the current sources. So normally what you do is that you node, see here you have current I1 is entering. Okay, so
Okay.
you even have to assign. So this is the datum node here. This is the 0 point here. Okay, so
Yes, sir.
between this and this is the first point. So this would be, this impedance here would be equal to Y10, right?
Correct,
Similarly,
correct.
similarly here, the second datum node you have to take here. This is the 2 node, and this impedance here would be equal to Y20. Which one? This impedance Y20. So Y20 is equal to this part, and Y10 is equal to minus J1. Got it?
Mm-hmm. Yes, sir.
Now if you have to suppose, you have to write the value of current I. Okay, now you see, according to the KCL equation where I1 is entering, uh, and I1 is getting inside Y10, right? Y10. See, I have in the very beginning I wrote somewhere there, which was that, yeah,
Y
this
is equal
equation,
to
yeah,
minus.
but I have wrote this equation I is equal to V into Y, right?
Okay.
Because
Yeah, yeah.
no, normally I is equal to V by Z, okay, where you have
Okay.
V into 1 by Z,
Yes, sir.
and
Where Z is a, yeah,
1 by
impedance.
Z
Yeah,
is
got it,
Y,
got it, got it.
so this is
Got
V
it, got
into
it.
Y, right? This is V
Yes, sir.
into Y. So now here you would write I1, you have to start. So can you tell me what would be the voltage at this point? Voltage at this point, see, I1 is getting divided. Okay, so I1 is getting divided at this point. This is Y10, right? Into what is
Y10,
the
correct.
and the voltage due to this is V1, right? At this point, in the starting point, voltage is V1, and at I2 the voltage is V2. So the first voltage will be Y10 into V1. Okay. After
1 0
that,
into V1. Yeah, yeah.
yeah, after that, you see what is the potential drop between this point. This point voltage is V1, right? And this point
Yes,
voltage
sir.
is V2. Okay. So the
Correct.
potential difference between them is V1 minus V2. Okay.
Yeah, yeah.
The potential difference is V1 minus V2, and the impedance that is connected here, you can see impedance that is connected here is Y12. Can you see this Y12?
Yes, sir. Yes, sir.
So this would,
Y12, which is minus J 2.5.
no, no. First, let me write in terms of, I will not put the numerical values. I will just put those
Okay. Got it, got it,
signals.
got it.
Yeah, Y12. Can you tell me the third point? What would be now Y13? Now
Sir,
see this current. If you see over here, this current goes at this node and it gets divided here. Okay, and further it gets divided at this point. It goes here and here, right? Can you see
yes, sir.
this current?
Yes,
So
yes,
for
sir.
first equation I wrote for this point. This is, I will write one. This I wrote for this. Second point I am writing for this, right?
Yeah.
This is the second point I wrote for this. Now the
Yes, sir.
third point is this point. Third point current is getting divided.
Y13.
So Y13. Okay. Then, but what is the potential difference between this point and this point? Can you tell me what is the potential
That
difference?
is
Suppose this
the
was V1, this is V2, this would be definitely V3,
three.
right? So
Yes,
can
sir.
you tell me what is the potential difference between them? V1,
So V1
V1
minus V2
minus V3. So this is V1 minus V3 is equal to V1 minus V3 into Y13.
into Y13. Yeah.
Okay, this is the value of I1. Okay, similarly,
Correct.
can you tell me about I2? I2 is starting from there. Can you tell me
So,
for I2?
yes, sir.
I2,
I2
I,
would be
first value would be C. First value for I2 is
Y20,
Y20, good, in
Y20 into V2,
into V2, nice. Then
plus
uh,
V2 minus V1
plus V2 minus V1, very good,
into Y12.
into Y1,
1, 2.
Y1,
So 2, 1, 2, 1, 2, 1.
Y1,
Like,
no, no, Y12. Okay, yeah, see, if you Y12, Y21, okay, yeah, carry on, carry ahead then. Hmm.
um, plus V2 minus V3
Plus
plus
V2, uh,
V2 minus
uh,
V3
plus V2
into
minus V3 into
into Y23.
into Y23.
23.
Okay, these are some of the values. Then if you look at the impedance between V3 and V2, if you look at Y23,
Four, sir.
if you look at Y23, Y2, if you look at this Y23, you are looking right this Y23,
Yes,
and
sir. Yes, sir.
between V3 minus V2, okay, this current, okay, this current
Yeah.
plus this Y13 current and plus this Y34 current, because these are meeting current meeting at a point. would be equal to 0, right? KCL
Uh-huh.
also states that current, all the currents meeting at a point is equal to 0. So this would be equal
Yes,
to
sir.
0. Which values would be equal to 0? First is this
Sir,
y23,
Y13, sir, Y13 into V1 minus V3.
y y13,
Y13 into basically V1 minus V3 into Y13.
yeah, y13 into v3 minus v1, right?
Sir, V1 minus V3.
Where you have seen y13 into
So the current is flowing to 3, right?
yeah, y13 into v3. Okay, yeah, v1 minus,
V3.
yeah. Next equation you tell me.
Um,
v3 minus, wait,
sir, V1 minus V3 plus
v v1 minus v1 minus v3, right? Correct. Then
plus
plus, yeah, this is the
Y23
y23, correct. Hmm?
Y23 into V3 minus V2
Very good. Then
plus
plus
Y34
y34
into V3 minus V4.
v3 minus v4. Very nice. Now you tell me there is one more equation in this part. Okay, this current between v34 into y34. This is that part. This is not, but this is also you can equate it to 0. Okay. Last part is like this.
Yes, sir.
0 y34 into v3 minus v4, right?
Yes, sir.
This path current here. Okay. So this is also equal to 0. Now you can rearrange these equations. How do you rearrange these equations? If you open these equations, the rearrangement would be this part. I'll rub. I'll show the rearrangement here itself. The rearrangement part I'll show you. Oh, wait a second. Yeah, this is the whiteboard. This is the color. So you can rearrange this equation in this form. I1 would be equal to whatever the values that are associated with V1, we will segregate. What is the value associated with V1? Y10 is associated with V1. Then Y12 into V1. Then Y13 into V1. So I will take common V1 out and I'll write those equations. Y10 plus Y12 plus Y13 into V1, right? I have taken
Right.
this part. Then whatever things are
Yes.
associated with V2, I will write. Only you see minus V1 to V2. Then you have minus Y13 V3, right?
Yes, sir.
On similar grounds, I will do this. The same thing I'll do for I2. Common terms I'll take out. There is only one V1. If you look here, there is only one V1, that is minus V12 into V1. Okay, for V2, there are so many values for V2. You see, V2 you will have V2 Y12, V2 Y23, and again Y20 V2. Okay, so I'll take this common things. I'll write here Y20 plus Y12 plus Y23 into V2, and the remaining thing is minus V23 V3, right? Okay. Then again for the zero term also I can take out. So what I had written on the zero term, see, in the zero term I had written y13. Okay, what, basically you know one thing, y13 would be equal to reverse of minus of y31. If I want to write like this, I can write like this. So here if you look at this term, if I want to write it in terms of y31 or in terms of y13, so I can write this equation in terms of this value. 0 would be equal to minus y13 v1 minus y23 v2 plus y13 plus y23 plus y34 v3 minus v34 v4. And similarly here also I can write 0 is equal to minus y34 v3 and plus y34 v4. This can be written, okay, from here if I want to write, because this y13 and this matlab, it is just the direction of the current. If I want to express it in terms of y12 is equal to y21, okay, this can be expressed. I'll explain you how. This is like, there is a concept, uh, two port networks have you studied.
Sir?
Y12 is equal to, see, y12 is equal to y21. Okay, these terms, whether it is y12 or y21, this term would be equal to minus y12. So I'll be explaining you. So now I will try to arrange these equations for you. Okay. Now we
Yes,
will
sir.
introduce some of the. Have you taken it down? So this, why this minus sign is coming? It is coming because of this property of two port network. Okay. Y12 is equal to y21 can be expressed in terms of minus y12. That's why here, if you notice, there is no minus sign. But here, if you notice, I have introduced the minus sign. So don't get, because of this property I have written. Okay.
Right, sir.
Uh, there are so many basics are not there, because that's the reason you are getting a little bit confused. Otherwise, it is not
Right, sir.
difficult. Are you understanding?
Yes, sir. Yes, sir.
Any doubt you have at
Uh,
any point, you can ask me. I'm here.
no, sir. I'll just need to write a part. One second.
You write this part, then I will introduce the, so, introduce the matrix, and
Yes, sir.
introduce the matrix and introduce the form, how it is arranged. Okay,
Yes, sir.
how this is arranged in the matrix form. Then I'll explain you the Gauss Seidel method. And after this load flow, after explanation of the Gauss Seidel method, we will look for the, what is basically the power flow. So how this, you yesterday you were getting confused now, that KVL, KCL thing. Until and unless you
Yes,
don't
sir.
know this basic, you will not understand that part. This basic is
Right,
very
sir.
important. Okay, it cannot be avoided. Huh?
Right, sir.
Then you will say, sir, how this I1 is coming, how that I2 is coming, it will be a problem for me. Okay,
Yes, sir.
can I rub this?
So you can drop the down wala part.
Yeah, yeah,
Just
you take,
you will not drop the
this
right
part I
side.
can rub.
Yes, sir.
I
Yes,
will
sir.
also, wait a second. I'm recording this. I'll share the PDF part also. I'll save the PDF, as well as I will send you the text also. I'll also mention the
Yes,
number,
sir.
because the text that I'm following is a very good text. Hadi Sadat. I have a soft copy of this. Have you studied from this book? Hadi
No, sir.
Sadat. Hmm?
No, sir.
This is the best book actually to understand this in load flow studies.
Right, sir.
Power system analysis by Hadi Sadat. Okay,
Right, sir.
this is the, like, presently the book that I'm using to explain you this power system. It's a self-explanatory power system analysis. This is the one of the best books to understand
Got
these
it, sir.
load flow studies analysis. In your college also, they must be following some Hadi Sadat. It would be there in the library,
Yes, sir.
definitely.
Sir,
Huh?
I've seen, sir.
Huh?
I've seen, sir.
Yeah. Okay. Shall I now rub this? This
Yes, sir.
down part shall I rub?
Yes, yes, you can drop, sir.
Okay, down this part I'll rub. Okay, because arrangement
Yes,
part
sir.
I
Yes,
will not rub. I'll rub the down, this part.
yes, sir. Yes, sir.
Hmm.
So, or you can drop the whole thing, sir.
No, no issue. Because I have to. You should be also able to see that part. Huh? Then only you'll understand.
Right.
Okay. Now, today the good thing is that computer is not malfunctioning.
Yes, sir.
Otherwise, I was not understanding. It was problem with my computer, not with the network.
Oh,
Now you are not having any problem. I got a new laptop.
none, sir. None, sir. Perfect, sir.
Okay. Then up here. How I have to have, yeah. Like this. Once you take the rubber, then you have to go here. Take the pen. Right. Wait. Yeah, it's perfect. But whenever we uh, this color cannot be used, and why it's not coming that and whiteboard to show the whiteboard. Otherwise, it does not. That is one of the problems here. Yeah, Pranil.
Yes, sir.
Yeah, it's still recording. So, yeah, share this thing. Yeah. Now, okay. Yeah. Now see here. Can you see that these values? There, this value y10, y12, y23. Okay,
Yes, sir.
and this value here and this value here. Okay,
Okay.
so I express this value in terms of y11. So my y11 value would be equal to y10 plus y12 plus y13. Okay, and
Yes,
similarly
sir.
my y22. Okay, y22 would be equal to, can you tell me, y20 plus y12 plus y23. Okay,
Right, sir.
and same case for this, it would be equal to y33. Okay, so can you tell me what is the value of y33? I have drawn y33 would be equal to, here it is, right?
Sir, Y13
Y33 would be equal to y13 plus
plus
uh,
Y23
plus y23, correct, plus y34.
plus
Okay,
Y34.
4. So this value you can see over here. Okay, and one more thing is that then my y44 value, y44 value, can you tell me what is my y44 value?
So that is just Y34.
That is just y34. Nice. So you're understanding. You have studied prior to this, you have studied load flow in some semester or
Yes, sir.
not?
Yes, sir. Yes, sir. Yes, sir. I have, sir.
Then why you are like not properly studied, huh?
Yes, sir. Sir, it's very here and there, sir.
Okay, yeah, yeah, it's very here and there. It does not. Okay, so no, here in the from this book now, if you study, it is in very good shape. Okay,
Got
then
it, sir.
yeah. So y12 would be equal to y21. This we'll write as minus y12. Okay. Then similarly y13 would be equal to y31 would be equal to minus y13. Right. Then on similar grounds y23 is equal to y32 is equal to minus y23. And on a similar grounds y34 is equal to y43 is equal to minus y34. Now I can arrange this whole equation in a form of a matrix. Okay, so this form of the matrix, see, if you look at the above equation, there is no connection between bus 1 and 4. Is there any connection? This is my bus 1
No, sir.
and this is my bus 4. So if there
No,
is
no direct connection.
there is no that when there is no direct connection between 1 and 4, so we can write that y14 and y41 is equal to 0. And which part is not having any direct connection, any other two nodes which are not having connection, there
Sir,
is no
2 and
connection.
4.
2 and 4 is also not having any direct connection. So because since these are not having any direct connection, since nodes 1 and 4 and 2 and 4 are not having any direct connections, not having direct connection, so we can say that my y14 is equal to y41 is equal to 0. On similar grounds, I can write y24 is equal to y42 is equal to 0. Now, if I have to write, suppose I have n number of equations, n number of nodes. This we have considered for how many nodes? 1, 2, 3, and 4. Okay.
4.
The same thing, the same relationship can exist for n number of nodes, which can be written in this form. Okay, this can be written in a generalized form, and the
Yes,
generalized
sir.
form. Can I rub the above part now? Since the below part is there,
Yes, sir.
now
Yes,
I'll
sir.
rub
Yes, sir.
this
All
part.
done, sir.
Yeah. So So the generalized equation for this would be, yeah, here, yeah, this is a little bit, yeah. Then you have to go for that. Here it went. Yeah, whiteboard. So this generalized equation I can write in this form. I can write I1 would be equal to V11 plus Y12 V2 plus Y13 V3 plus Y14 V4. Here you see this term is not there. But if you look at this I11, when I had started from that equation, I had written I1 is equal to V11 V1. First part was there. Then V12 V2. If you look at your look at the text what you have written on similar rounds, you can write I2. Can you tell me what you can write I2? First equation would be for I2. So first term would be what? Hmm? Hello?
Sir, Y2 V1. Yes, sir. Yes,
Y2,
sir.
first term would be Y21 V1, right? Second
Yes,
term
sir.
would be
Y2 1 V1.
second term, second,
Y, sir, Y2 1 V2.
no, Y21 V2, how it would be? First term is Y21 V1, right? Second term is your Y22. Second term, in the second term only
Okay, yeah,
Y22
yeah, yeah.
came.
Correct, correct, correct. Yes, sir. Yes, sir.
Yeah,
Yes, sir.
Y22 it came, right?
Uh,
Y22 V2. And in the third term, you got Y23 V3, right? If you look at the terms associated with V3, it is Y23. If
yes,
you
sir.
look at the terms that is associated with V3 is Y23 V3.
Got
Okay,
it.
so same term. So see Y23 V3, and similarly for the this term it would be Y24 V4,
Which
and
is 0.
which is okay. Now since it is having two currents, okay, so rest is zero. But suppose it was having still more number of networks, still it was having I3, I4, other values it was having, then you would have written V31 V1
Accordingly.
accordingly plus V32, okay, V2
Yes, sir.
plus Y33 V3 plus Y34 V4 and
Oh,
so on and so forth. So I4 up to IN. See Y41 V1 plus Y42 V2 plus Y43 V3
V3.
plus V44 V4. So if you have an equation IN, so for the equation IN, what would be the first term? YIN, right?
Sir, I and yes, sir. I am, sir.
YIN V1 plus YN2 V2, correct?
Yes, sir. Yes, sir.
Plus
Yes, sir. Right.
YN3 V3 plus YNN VN, right?
VN. Yes,
Can
sir.
you, yeah, yeah, it's like that only. So
Got it, sir.
can you, this whole equation, can you put in a matrix form? So have you noted it down? Because I will clear this now. Huh?
Sir, 1 second, sir.
Write it down because it moves. Yeah. Okay. You by the time you rub, I'll rub from here. So okay, this part I
Yes, sir.
will note that down.
So the meeting is about to end in 2 minutes, sir.
No issue. I'll take one more class now because
Yes, sir.
I'll
Yes, sir.
send you another link. Okay. You take 10
Yes, sir.
15 minutes
Thank you,
break.
sir.
After that, I'll send you link. By the time, the moment it stops, no problem. We'll resume from that point only. No issue.
Yes, sir.
Uh,
Yes, sir. You can erase the whole thing, sir.
that whole thing I can erase. But I
Yes, sir.
wanted to show you something now. This I need this
Okay, right,
part
right,
of.
right. So you can start, sir. I'm ready,
Ha
sir.
ha. So yeah, the only thing is that here pen, once I am using this eraser, the pen is getting, the pen thing is not coming. That is the
Yeah, sir.
problem. I have to again go and go for this. That lag is there. But anyways, it is
Oh,
much better than our previous
the
classes.
previous. Yes, sir. Yes,
Yeah,
sir.
it is.
True, sir.
It's much better with the new because it will take me some time. There are some different functions in. So this whole thing I can write in the matrix form like this. I can write this whole thing. I can write here I1. I can write I2. Similarly, II up to IN, and here I can write the
Yes, sir.
same thing in this form. That is your V11, V12, okay, V1I, V1N,
Yes,
and
sir.
same thing here also V2, V21,
Okay, basically depending on the
V2,
number of
yeah,
currents.
V2I, yeah, it depends upon the number of currents basically. Okay,
Yes, sir.
why if we see, and I will generalize, I'll write a generalized equation for this. That generalized
Yes, sir.
equation only we will be using when we are solving the problem. That generalized form only we will be using, so that you don't get connection any doubt. Yn1, Yn2, see here I have written Yn3 and Ynn, and here this value, this is called state space form. In control theory